Hey everyone, here are your notes for non-translated hyperbolas that you might want for your test coming up. The formula looks very much like an ellipse, except there's a minus sign in front of it. And the other big difference is a squared is always first. So in this example, the x squared and the y squared might switch, but a squared is whatever's first. It's not what's biggest. So that's another big difference. And whatever is first tells you what direction it goes. So when I say it goes in the x direction, it's pointing towards the x-axis, and this one is pointing towards the y-axis. So a squared, I said, is the biggest, not the biggest, it's the first denominator, and that tells you where the vertices are. The vertices are basically the vertex of both of the branches of your little parabola branches. And then the other big thing is the foci are going to be inside the branches, like eyes still. They are inside, but the formula is different now. It's not a squared minus b squared is c squared. It's a squared plus b squared equals c squared. And you can remember that because it's the opposite of whatever the sign is in that formula. Okay, here are some steps. You'll always find your center first. Figure out what A is and count that direction to get your vertex. Then what you're going to do is you're going to count B from the center in the direction of whatever B is under. And what we're going to do is we're going to make a little box. Basically where the ellipse would have been, we're going to make a little box. We will draw little diagonals going through those. Those are actually called asymptotes. And then we will fit the branches of the hyperbola in where they belong. Okay, so we are going to do this first example. I think I can maybe find it here better. Doggers, that's 7 2. Not what I want. Oh, there it is, 7 3. Okay, so a hyperbola, I didn't give you the definition or a picture this time, but this time the difference between those is constant instead of the sum. They didn't show the box here. Oh, there it is. Okay, so this is what I'm talking about, the box. So basically we would have drawn an ellipse in here, but now we're going to draw a box. And then there's these asymptotes that come through, and you will need to find the asymptotes. The asymptotes are going to be easy today, and they will be trickier on Wednesday. And then you can see you can just fit the hyperbola branches in there to hug the asymptotes on the end of those boxes. Okay, so let's look at this one. Okay, well, it doesn't equal 1. And it always has to equal 1 first. I'm trying to give myself some workspace here. So I'm going to divide everybody by 144 and simplify the fractions. That's not a new process for us. Okay. Divide by 144. Divide by 144, divide by 144. Okay, simplify the fractions. 9 over 144, you can use your calculator if you want, but that's x squared over 16 minus y squared over 9 equals 1. Okay, so things I know now. I know it's a hyperbola. First of all, it'll probably tell you it's a hyperbola, but the minus sign here is important. The center is 0, 0, because today all the centers are going to be 0, 0, and basically there's no parentheses by the x and y. Now, x squared is first, so that means it's going to go in the x direction, which is this way. A squared is always first. A squared is 16, which means A is 4, and that's in the x direction. Now, those are going to be your vertices. So those are actually points of the hyperbola. The vertices are going to be at 4, 0 and negative 4, 0. Now we'll go in the B direction, 3 and 3. And those are not points on the hyperbola. Those are just going to help me draw in my dotted box. So you draw in your dotted box. It used to be that's all you would do for your ellipse, but now we're drawing a dotted box there. And then you're going to draw your asymptotes, and the asymptotes will go from the corner through the center, and you will have to write the equation of the asymptotes. So for those asymptotes, since this one you can see the y-intercept is 0, it's mx plus b, so you need to figure out the slope. You're rising 3, and you will always rise one of these numbers. rise 3. So I'm rising B, and I'm running A, which is 4. So it's 3/4 X. And there's always two asymptotes, and sometimes they're opposites whenever it's at 0, 0, but a lot of times they're not exact opposite equations. But this one will be negative 3/4 X. And we can draw the branches in because we know where those go, and they just hug those asymptotes. Oh, that was not as good over there. Okay, and the last thing I have to do is find the focus, which is going to be on the inside. So it'll be a squared plus b squared equals c squared. 16 plus 9 is c squared. 25 is c squared. So 5 is c. You count from the center, and it will be on the inside. There's a focus. There's a focus. So we are at the foci, that's more than one focus, are at 5, 0 and negative 5, 0. Okay, so a lot of it is like ellipses with the addition of these asymptotes, a different equation to find C, and a box instead of the ellipse. Okay, I think I have one more here. Okay, this one, find an equation of a hyperbola. So it says it's a hyperbola, so it's something minus something equals 1. And this says the vertices, so I'd sketch first at over 0, down 4. So what does that tell me? That tells me, since that's the vertices, that it's in the y direction. So that means y squared has to be first, and x squared has to be second. Vertices tell me what the a is. So a is 4, a squared is 16. So a squared is always first. And then they told me the foci. Well, the foci has C in it. It tells me C. C is going to be 6. I don't know. So C squared is 36. So now I still have to know what B squared is. So remember, it's A squared plus B squared for hyperbolas is C squared. A squared is 16 plus B squared is 36. And I don't have to find B. I have to find B squared because that's what goes in the formula, and B squared will be 20. Okay, that's it for the notes. I'm going to go ahead and do the math lab assignment. You don't have to do the math lab until tomorrow. You just have to take notes today, but a lot of you like to work ahead on that. You will need to get some of this done to get the participation points for this week. So you might want to go ahead and do that, and I will talk to you guys soon.